Welcome to Dig Deep, the mining podcast. In this podcast, we go deep into mining news, hot topics, and live interviews with mining professionals and leading figures in the mining industry. Introducing your host, Rob Tyson, founder and director of Mining International and Mining International Executive, a leading global mining recruitment and headhunting agency.
Hi mining community, welcome back to another episode of the Dig Deep, the mining podcast, and today's guest is Adrian Dance, who's the principal consultant at SRK Consulting, who are independent and international multidiscipline mining consultancy focused on providing advice and solutions to clients, mainly in the earth and water resources industries. They offer services from exploration to mine closure and are specialists and leaders in the fields such as due diligence, technical studies, mine waste, water management, permitting and mine rehabilitation. Adrian's expertise is in metallurgy and mineral processing and has worked for the likes of Mount Isa Mines, Highland Valley, Bisha Mining before joining SRK back in 2010. And he's going to be talking about the technology in mining, talk about also the XRT and also looking at, I suppose, different types of mineral processing, and also about ore sorting. So many things. This is going to be a little bit more of a technical podcast. So for those that are not in mineral processing, maybe it's something you might actually learn something from this episode. Also want to give a shout out to our sponsors, Hawcroft, who are leaders in property risk management in the mining industry since 1992. They offer insurance risk surveys, construction risk reviews, asset critical assessments, and more. They work across 600 sites globally and support all areas of mining and resources within our industry. So if you're looking for any property and insurance risk management services, then obviously visit their website at www.hawcroft.com. All the details are in our show notes. Adrian, welcome to the podcast. How are you doing?
Very well, thank you, Rob. Thank you for having me a platform to speak to your audience. Thank you very much.
No, I appreciate your time also. As we always start these podcasts off, just wondered if you just obviously tell us a little bit about your background, your career. As I mentioned, you're an expert in metallurgy and mineral processing, which is what obviously this podcast is mainly about. So just wondering if you just run us through your career, how it's developed to what it is today.
Certainly, Rob. So I got into the mineral industry here in Vancouver, Canada. I enrolled in a Bachelor of Engineering degree here, which was a combination of mining and mineral processing. I ended up being a bit more fascinated by mineral processing than the mining sector. And so I followed that up and ended up going to Australia to study at the Julius Kruschnitt Mineral Research Center, or the JKMRC in Brisbane. And I ended up getting a doctorate in mineral processing there, doing applied research. So everything in the research field was done in the field, sponsored by the industry. And I ended up with a PhD in separation of mineral sands. Unfortunately, when I graduated, mineral sands was not doing well and couldn't justify me going into the industry. So I ended up getting jobs, as you said, in far north Queensland and Mount Isa Mines. I ended up becoming a consultant in grinding, comminution, which carried me through a lot of my career. Spent some time at Highland Valley Copper here in Western Canada, and then went down to Peru at the Antamina mine. Returned to Australia to be a grinding and crushing and grinding consultant, doing a lot of optimization exercises where I'd go to an operation, see what they were not quite doing right to get the process to work better, and showed some really significant improvements of what's possible with changing the material properties to get it to process better. And generically, that became an exercise called mine to mill, which I think has moved around the industry a little bit, and people may have heard it as a term. But when we were starting to do it in the 1990s, it was perceived as magic, voodoo, shameful. I can't believe that you're even considering such a thing. And what that really entailed was crossing over the silos that exist in the mining industry between the different disciplines, which is possibly a topic we can get into. Is that what's holding back efficiency, in my opinion, is the silo effect of different disciplines: mining, feeding processing, feeding smelting, everybody doing their own job, but not really looking at the holistic type of approach of how we can do things better as an industry. So I did 20, 30 years of optimizing through mine to mill, which is looking at one aspect of the material coming into the plant. And now with SRK, I'm continuing down that path of how we can best improve the quality of the material being processed. Our methods of processing have not really changed much in 100 years. We call things differently, but the process is the same. But what we really need to be considering now more than ever is improving the quality of the material coming in to really improve the economics. So the story from my career has been not necessarily to take the status quo and say, oh, well, that's just how it has to be, but to question. And increasingly, technology is available that is applicable to the mining industry, but we are generically slow to adopt. And there's a lot of reasons for that. But reminding people that technology is equally applicable to the mining industry as it is to oil and processing or oil and gas is an aspect. And one of the things that different people can talk about is the fact that we are losing expertise. We are not really getting a lot of traction of people coming to the industry. And potentially we are going to be overrun with computer-focused people using the AI conduit to come into the mining industry. And fundamentally, the knowledge that we've gained could be dealt with that way. But there's a lot of things I've wrapped up in your original question, but that's my background and attitude.
Yeah. Obviously, you just mentioned technology. What's your, I suppose, background in applying technology to obviously the work and projects that you've been doing within the mining industry?
Yeah, and so again, a lot of the areas that I've been focusing on has been taking an existing operation and improving how it runs. And the challenges you see there are not technical ones. I would argue that every operation could not benefit technically by some changes. The challenge is the ability of people to accept the change and to take ownership and confidence that these changes can be sustained. We have an industry that believes it's not well quantified, and the variability and uncertainty in what we're doing overshadows everything. And so consequently, it's very easy for people to say, well, it worked when you did it, but it's Tuesday now, so Tuesdays it never works. And we're full of reasons / excuses as to why things don't work, and we seem to be very comfortable with the status quo. Now, increasingly, we have access to information at the second by second scale. There is technology out there to scan core. There's technology to scan blast holes, to constantly measure the material moving from the mine into the plant and onwards on a minute by minute basis. So we're not lacking in information. We're not lacking in numbers. We are perhaps lacking in data or knowledge. And so consequently, we're on the cusp of potentially really using this information, but what's lacking is the decision making and the options to do things differently. So, example, we have a wonderful whiz-bang machine that tells us the material is going to be very hard tomorrow. Great. What are we going to do about it? I don't know. I just tell people it's going to be hard and we're going to do poorly tomorrow. Instead, we need things that say we need a flexible way of processing. We need alternate ways of processing. We need different paths for the material to follow that is suitable for the changes in the properties. And that's where we need as they say, a real significant change in how we do our business. But increasingly with metal prices and the demand for metal, et cetera, we have no choice but to change how we do our business because it cannot continue down the path that we are. We've gone down the path of larger and larger equipment, larger and larger plants, economies of scale. But that's not smarter, that's just bigger and faster. And we need smarter processing for our dumber ore bodies, for our material that's challenging, that's low grade, that's hard, that's remote, and very often contains impurities that we don't want in our final products. So all of these things are not going away. And I see SRK's role, and it was said to me once, SRK Consulting should be considered the thought leaders. And as thought leaders, we should be questioning and also revealing the opportunities that are out there to do things differently.
What would you say the main advantages of using XRT over traditional sorting methods? And in what types of deposits do you think it's most effective?
So the element of XRT, or X-ray transmissive sensing, is one aspect that we're investigating. So going on from the mine to mill studies and projects and optimization that I mentioned, the next round, the next level, the next dimension of improving the feed properties is to look at the huge amount of waste material that's getting carried through in our ore streams going into our plants. If it's not clear to the audience, a gold deposit now, we will process a 0.5 gram of gold per ton of rock. And if it's not clear what a gram is, it's a paperclip. So 1/2 of a paperclip of gold per ton of rock is being processed with power, water, and ultimately ending up as a tailings storage facility that needs to be looked after in perpetuity. If you take somebody outside of the mining industry and say, we're going to process 99.999% waste to get to that 0.001% valuable, someone would say, check your head, because it's ridiculous. So the next round of ore quality is the opportunities to remove the waste that is brought in through our mining process, through the way that we do our business, and rejecting it at the earliest possible stage. So generically, we're calling that pre-concentration. And it's in our definition, it's when the material is coarse, when it's still dry, so there's been no water added to it that's getting consumed. There's been limited amounts of energy or power applied to get it to minus 200 millimeters onto a conveyor belt. So it's coarse, dry, and it can be rejected either on a conveyor or can possibly even be trucked away. So SRK, myself, and Bob McCarthy in the Vancouver office have been looking into how we can get pre-concentration considered at every project as early as possible. And one of the things that SRK has is a vast array of global clients that we are looking at early stage studies. So we get in there when there's nothing but drill core. We get in there when it's just a concept, when people are wondering what they can do with this deposit. And we get in there and we say, look, it makes a lot more sense to look at rejecting waste as soon as possible. And what we've been developing is a method to evaluate deposits as well as a independent test that can look at whether or not material will be rejected at a coarse scale. Now, what's been lacking is the only people who've been commenting on whether or not sensor sorting works are the manufacturers. They are the experts. They have decades of experience in other industries and in the mineral industries on whether or not sensors can be used to look at the material. However, they are not independent. fundamentally, they look at it from a perspective, as they should, of selling equipment, selling technology. So what SRK has been working on is a least disruptive way of evaluating if waste can be rejected before it gets into the plant and before it ends up in the tailings pond. And to do that, we have been looking at a range of sensors. One of the most common ones is X-ray transmissive. And to show our support, we have co-purchased a laboratory XRT sensor unit with our local lab here in Western Canada called Base Metallurgical. They are a commercial metallurgical lab here in Western Canada, been around for quite a while now in their existing company and previous met labs. And we are the owner of a small XRT sensor unit. Now, what that does is it really is like looking at a baggage scanner on your rock. So when you've gone through security at any airport and you look up the scanner, the black and white image, and what lights up is the metal that you shouldn't have in your bag, and what is dark is stuff that's not metal. That is an XRT scanner. We are using the same technology tuned to rocks to look at where the metal is in the rocks. I mean, I'm speaking crudely here, but it's largely correct. So where we can see the hot spots of the rocks and the cold spots of the non-metal, that will tell us whether or not we can throw those rocks away. As crazy as it sounds, when we look at material, we tend to take all of the material, crush it all down, and get a single measure of grade or an assay. What we're doing here is we're isolating the rocks at the largest size we can get our hands on to see whether all rocks are created equal. And XRT is one sensor that allows us to look into the rocks, through the rocks, to see where the metal is. And it's very interesting. It's very illuminating. It's very, as a researcher, it's fascinating to find out that metal is not equally distributed amongst all rocks. And with that knowledge, you can really ask yourself, why are we sending all of this to the tailings pond? So it's a disruptive technology, meaning to include it now into our flow sheets, people are just not ready for it. They're like, yeah, but how come? What am I going to do? I'm just not ready. It's not something I'm used to doing. And we're yet again faced with a new idea, change being implemented in the mining industry. So again, what SRK is doing is we're making it easy for you. We're saying, we will evaluate your project. We will tell you what the economics is on whether or not this makes any sense. Because one thing the industry is very good at is advertising failures. So people who are running at sensor sorting, particle sorting, bulk sorting, whatever you want to say, and going, oh, it sounds great, we're going to have to do it. And they do it without a thoughtful, scientific, logical process. When they fail, they will tell the world how well they failed. And that is advertised like wildfire in the industry. And, oh, did you hear what happened? Oh, my God, it was a disaster. And that is spread wildly. And so the biggest thing we want to do is to avoid people from shooting themselves in the foot with this technology, and to only apply it when it makes economic sense. And in a way, what we're doing is we're sorting out the projects that should consider sorting. And by doing that, we increase the chance of success. We increase the chance of the industry adopting this and realizing where it can be done. If I could digress for a moment, and I know I haven't given you a chance to ask me another question. My background is in grinding. And initially, in the 1970s, slightly before my time, we would have lots of crushing, lots of little mills, et cetera, et cetera. And somebody came up with a new technology that they said, let's get the rocks to break themselves. Let's call it autogenous grinding. Sounds great. We'll use the rocks to break themselves. And somebody said, if we build a mill that's really, really tall and let the rocks fall on themselves, they will break themselves. and we will have autogenous grinding. Oh, fascinating. Sounds great. I've never seen one before. But at the time, they said, oh, only a certain material is suitable for autogenous grinding. It has to be the right type of material. Not all material can be done this way. Oh, well, how do we find out it's right? Well, you have to do a pilot test. So the only way to do an evaluation if your material is suitable for this new technology is to run a little mini pilot plant. Since then, we have developed bench scale, lab scale measurements that allow us to predict whether or not a pilot test is needed. And we've learned that, in fact, just about any material can go through this magical technology called autogenous grinding if you know what you're doing. And now everybody's milling with semi-autogenous grinding or autogenous grinding and so forth. But I see sensor sorting in the very same light. It's magical. It's new technology. Is my material suitable? Did you hear about the disaster where they tried to use it? And the only way we're going to know if this works is to run a pilot scale. That's where we are. So fast forward, and I don't want to wait 20 years because I won't be in the industry for 20 more years. Fast forward 20 years, somebody's developed a bench scale test to predict this. And that is what we've done. We've produced an industry-wide standard test that we are not concealing from anybody. We are not charging any fee to run the test. Any lab can do it. We want everybody to do the same test, and consequently to learn when or when not this technology can be applied, and to get rid of the magical nature of it all. So we are going down another path of technology in the processing industry that seems to be and smell and taste and looks just like where we were for autogenous grindings back in the 70s and the 80s. So we are seeing sensor sorting as the way to go. We are currently looking at X-ray transmissive because it's penetrative. It sees through the rock. We are getting access to other sensors, for example, X-ray fluorescence, which looks at the surface. For example, magnetic, for example, color, for example, laser. In my opinion, sensors will be developed, but the industry needs to demand it. Asking somebody, can you develop me a new sensor to do this? If you show there's a market for it, the sensor will be developed within a year. But we need to be ready for it. So we shouldn't be waiting around for the perfect sensor. We should be doing what we can with the current sensors and then attract the electronics industry to ruggedize their sensors into something that we need. But because we move at a much more geological time span pace, we need to be ahead of the sensors so that the sensor companies see the demand and build the sensors for us. So there is a vast range of sensors out there, but what we are advocating is not so much you have to do this, but evaluate your deposit. Find out if it makes sense and then investigate it. But don't do it if it doesn't make sense, and don't go down the path. So we're not in any way saying sensor sorting is perfect, sensor sorting is wonderful, everybody has to do it. We're saying we are offering a way to evaluate sensor sorting for every operation when they're still at the conceptual stage, which is when projects need to really consider this. We're dealing with projects now where the mine is so remote, they're sending the material tens of kilometers to thousands of kilometers to be processed. And if you can reject 40% of that material at the source, it's a no-brainer. But what's happening is we don't have a proven, we don't have a method the industry has accepted yet as being the way to evaluate this. And that's where we're using the SRK Global Network to tell people about what we're doing so that they can evaluate themselves, they can see it's possible, and they can see the benefits of every operation, be it a project study or be it an existing operation that's processing low-grade material at the end of its mine life.
I suppose following on from that, what are some of the biggest misconceptions about obviously sensor-based ore sorting, and how should mining companies evaluate its suitability for their operations? And you have covered some of that though.
Yeah, I have. I apologize. But yeah, the misconceptions are very much people have a gut feel whether it's going to work or not already. And I personally am not a fan of guessing. As a researcher, as a scientist, as an engineer, I tend to say, show me the data. And to go, no, it won't work for us. It doesn't cut it. And that's been the mining industry's go-to expression. Oh, I don't think it's going to work. See you later. So misconceptions are things like, oh, it's very, very small scale, low capacity, it's very finicky, and oh, you have to get things just right or it won't work. And a lot of that, in my opinion, is coming from the manufacturers who are saying, to get the best out of our unit, you have to run it under these conditions. Well, you don't have to run under those conditions. I remember recently talking to a German manufacturer who were saying, you have to feed the material this way. And I go, well, what if we don't? And they went, no, you have to do this. And we said, no, we're going to run it the way we want and appreciate the benefits that may not be the best possible. So a lot of the attitude, I think, towards sensor sorting is the belief that it's very fragile, very low capacity, very delicate. And there are new designs coming out now, which I applaud, which make sensor sorting units look just like a cone crusher. It has no more of a footprint, has no more of an impact on the circuit. And that is what we need. We need to have something that doesn't look like a delicate piece of equipment being used outside of our industry. The other misconception is the only way I can evaluate my material is to do a pilot test. I was recently at a conference in Ottawa where an engineering company presented ahead of me on the sensor sorting forum and said, we've rejected the concept of sensor sorting not because it won't work, because we don't think there's a way to evaluate it at a small scale. That says to me that my mouth is not big enough, and I haven't got the word out that there are options available to estimate the performance without doing a pilot scale run. So that's part of the reason why I'm here now, to tell everybody that there are methods to contact us. We are advocating a way for anybody to look at this sort of thing. The economics, when it works, is unbelievable. And the misconceptions, I believe, come from the way things have been and not how they are at the moment.
Are there any innovations currently being obviously developed that may compete or even complement XRT technology in the near future?
Well, one of the things that is being clear to me that people are becoming more aware of is that very often in our ore bodies, after you blast it in its mined, the metal is not all sitting consistently throughout all of the sizes of material. Some of the big boulders may be barren of metal entirely. And as crazy as it sounds, as simple as it sounds, simply screening the material after blasting or after initial crushing can really produce a big upgrade. And we're seeing a lot of companies now going, that's interesting. I wonder if that's possible. And the challenge has been, how do I evaluate this? How do I get the samples? How do I prove it to myself that this can be done? And this is particularly true for gold operations that are going back into material that's low grade, that's being deposited in a way that we don't know where the material really is. It's very heterogeneous, as they say. It's not homogeneous. And so simply screening alone can produce an upgrade. It may not produce the level of upgrade that you're looking for, but it can certainly enhance. And one of the things that particle sorting always demands is a certain range of particle sizes, which has been another fussy part of a particle sorter, is it needs to be a certain size particle. Therefore, we need to screen the material beforehand. And one of the things that what we're doing is using our background in crushing and grinding and material characterization is we can estimate how much of the material will be too fine to sort, and therefore how much will bypass the upgrade, and whether or not that material upgrades itself. And in a lot of cases for gold deposits, you can see a significant upgrade. We're talking about 2 times the grade in the fine material compared to the entire material that you're processing. So that material is twice the value compared to everything else. So to answer your question more directly, looking at the combination of sensors, looking at the combination of crushing and screening with sensor sorting in a pre-concentration flow sheet is what we're looking at. So one of the things I've been advocating is that every time you touch the material with a crusher, with a mill, before it gets too fine, we should look at it and say, what have I done to it? Have I changed where the value is? Can I exploit it? And rather than just simply send it all down the line and have it end up in the tailing pond. And one of the things about the new circuits that are being used, because of the movement away from a single mill, the multi-stage crushing circuit is coming back for various reasons, and that offers tremendous opportunity to take the coarse particles that are being recrushed and recrushed and recrushed and go, whoa, 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 stop right there. That doesn't deserve to be crushed. Throw it away. It's not worth it. And the idea that the energy being consumed in multiple processing actually makes that material more costly, makes it a higher cutoff grade, is something that we should be embracing. All ore is not equal, and we should not be treating it that way. We should be exploiting the differences.
AI is rapidly transforming industries, obviously across the world and every industry. How is SRK Consulting incorporating AI into obviously their mining projects? And what do you see as obviously most promising applications in the field at the moment?
So I have to, speaking for my colleagues, my understanding is that the most rapid uptake of AI is in automated logging of drill core, automated analysis of material down the core, be it geotechnical data, be it geochemical data, etc. And the ability to, if it's not clear to your audience, typically once you've drilled a hole in the ground, the typical number that you look at is every meter. You'll get a sample and analysis every meter. We're now talking about using AI to fill in the blanks, to get information on every centimeter or every millimeter, and core scanning and the AI pattern recognition of all of that data is certainly where we're making strong inroads. And then ultimately the AI's interpretation of the drill hole results and exploration is another big one. These are both areas of not my expertise, but certainly AI's ability to rapidly summarize and interpolate data at a much higher frequency scale is a great application. Moving into the mineral processing space, AI is trying to make inroads. And again, where I see the barrier to that is not, can it be done? Yes, it can be done. AI can tell you some greatly insightful things. What's missing is our ability to do something about it. So AI can say, oh, here comes some material into the plant, or you don't add that material plus that material because it ends up in something you don't want. We need, as an industry, to have a flexible processing routes to allow us to receive this information and do something about it. So AI is great for static analysis, interpretation of something that doesn't need to necessarily be decided on. Where AI is going to hit a roadblock is when humans need to make a decision and we're not ready or prepared to make a decision based on those results. Potentially down the road, we could get pushed out and said, you haven't made a decision, so we're going to get AI to do it for you. But ultimately, we as an industry need to be ready for variable results, variable decisions, dynamic change to what we do, and not a static mine sending a static mill to a static tailings pond.
Grade engineering plays a critical role, obviously, in ensuring resource extraction in both efficiency and economic viability. Can you explain what grade engineering is and why it's such a crucial aspect of modern mining operations?
It's a term that I quote, and it's not my term. I wish it was. I love it. It came out of the Cooperative Research Center in Australia. So my background in Australia. And they had this term of grade engineering, is that don't live with the grade you are given, engineer it into what you want it to be. And so that's empowering. And a lot of the technology that I've been trying to apply into the mineral space has been about empowering people. When I was doing mine to mill work, I'd say to people countless times, I said, Mother Nature made it hard or soft. We make it big or small. We can overcome hard ore by making it small and easy to process. All of a sudden, people go, well, I haven't got an excuse anymore. So the idea of grade engineering is don't live with your grade. Even though it may be economic, it doesn't need to be that way. And grade engineering is looking at, and the term that they used was different levers, depending on how you say English. And there's things like differential blasting, screen upgrading, sorting, looking at all of these opportunities that once you've exposed the material and you have access to it, how can you improve it? In some cases, it's about taking the best part and throwing the worst part away. In some cases, it's taking the best part and sending it here and sending the worst part and sending it there. There's an operation that I visited some time ago in Zambia that had 3 separate process plants. One for sulfides, one for mixed, and one for oxides. Every block of material would be dynamically decided, do I go to plant A, plant B, or plant C? Now, that's not economic for every operation, but the concept of having something that be processed one way now and another way later on is not that strange, and that should not be discounted as silliness. We have a history of blending material together and hoping it will perform well. No other manufacturing industry would do that. And we are a metal manufacturing business. So if you think not as a processing person, but as a car manufacturer who needs to make so many cars, we wouldn't do business this way. And so grade engineering is the idea of not living with the material that you have, by understanding how it can be improved and how material that has found its way into the ore stream can be rejected. And that continues with downstream, with rejection happening later on. But fundamentally, we need the courage to look at our projects differently, and we need the tools and the confidence from people like SRK Consulting to investigate these alternate ways of doing stuff.
And lastly, obviously, given your experience in obviously metallurgy and processing field, where do you see the industry going over the sort of next 5 to 10 years?
Well, I've seen grades drop. I've seen material become more difficult to process. I've seen costs go up. I've seen recoveries go down. All of those things add up to increased metal prices. Now, and of course, the demand for metals, as we know, is increasing almost exponentially. And it's been very, very clearly documented. There's no way we can feed the electrification of the world with the amount of metals that we're producing now. And it's good to see a critical minerals list, and countries are becoming strategic about accessing critical minerals, and hopefully more and more metals get put on that list to be called critical. What that gives us is it gives us an opportunity to do things not necessarily at the lowest cost way of doing stuff. And that's where the industry has fallen down. We're undercutting everybody to be the cheapest producer possible and not the smartest producer possible. And if you look at things differently and say, you know what, there's economics in doing things smarter rather than cheaper, that opens up a whole new way of doing things. And pre-concentration is just one way. Mining wise, with more and more underground deposits, the only economic way of doing that is through mass mining methods. Mass mining, including sublevel caving, block caving, etc. It's the only way to economically do that. Those mining methods are increasingly unselective, which means we don't know what's going to go into the plant. So we need a plant that's more flexible, that's willing to reject, dynamically adjust to the properties that's coming in. So what's the plant of the future? It's where the money is put into the plant and not into the mine, and consequently continuous online monitoring of the material and a dynamic diversion and dynamic process change is probably where I see things going. Somebody asked me a couple of years ago, what's the next quantum change in processing? Is it more and more accurate modeling of what we do? And no, it's not. The quantum change is understanding what's coming into our plant on different dimensions and different aspects, and having the ability to do something with that information. Be it, sorry, it doesn't get processed, or no, it goes over here. No, it's going to be stockpiled until I change my plant to be processed later. So where is it going? It's going to a dynamic processing route, is how I would say it in one sentence.
Adrian, appreciate your time. Thank you for sharing your story, your career, telling us obviously the wonderful work that you're doing, research, and obviously with SRK talking about XRT, obviously the AI coming into our industry, and obviously in the processing industry as well. So really appreciate your thoughts and wisdom, and hopefully a lot of our audience listening to this, whether they're in mineral processing or even in mine engineering or geology, are taking some of your thoughts on board. If our audience wants to reach out to you, if they want to follow your story, how can they go about doing that, and what social media platform channels are you on?
Thanks, Rob. I appreciate this. Yes, I do encourage anybody to reach out to us and talk to us about what opportunities are there, if they have new projects or considering a revamp of their existing one. SRK's got a fantastic website being looked after by our marketing group. There's a lot of material that we're putting on there about pre-concentration. So srkconsulting.com, North America is the area to look at. The other area we're trying to post our achievements in is in LinkedIn. So connect to me through LinkedIn. You can find me quite readily. I'm probably the only Adrian Dance that looks like this. So please reach out through LinkedIn, and hopefully I can connect to people and spread the word about what tremendous opportunities are out there.
Yeah, great. We include those in the show notes that accompany this episode. So really thank you for your time. Maybe you want to come on next year and tell us about a new technology that's come up, or any thoughts that you've had, or discoveries that or something that you've discovered that could improve obviously mineral processing. More than happy for you to come on the podcast sometime next year.
Thank you very much for the opportunity, Rob. Appreciate it.
Yeah, no worries. Thank you. Hope you enjoyed the episode. As always, appreciate your continued support. Please keep sharing these episodes far and wide. This was a more of a technical podcast that we did here, so it should be spread amongst people within our industry, because if you're working in mineral processing, you'll probably agree with a lot of Adrian's thoughts. But if you're not in mineral processing, maybe something you might learn and take away with you. And as I think Adrian mentioned at the beginning, it's trying to look at the mining industry and your operation as a whole, not just each individual discipline that you may be working in. So thank you for listening. Keep sharing these episodes. And until next time, happy mining.
Thank you for listening. Remember to reach out to Rob via the show notes, and be sure to subscribe and leave a review. Until next time, happy mining, helping each other to improve the mining industry.